Okay, my friends, these are literally the stone balls they find all over the earth, but they are from giant creatures. Just a fact. Now, you see these bones? In between, they have what they call ligaments, and they hold the two bones together. Then you have other areas where bones go into your flesh, and then from out of the flesh comes all these little stalks that go to your muscles and so forth, and out of the bones. So your bone is here or your flesh is there, and these are all built into that fabric, and then coming out of it is a stalk that runs to a muscle, and then the muscle pulls back and forth like that. It's basically that way. Now, that is a bone head. And again, it's the kind of fossils I deal with. They're wet fossils, and they were preserved in a great salt flood. Now, this is exactly what you see here, right here. You see that? That ball right there. There would be a ball in here, a little tiny stalk, and another ball on the other side. Boom, they're like that. Now, they can do all these things, but they won't ever come apart, and they won't, because I'm telling you, this stuff is tough. Now, the other ones are like this. This is one of these balls. You see the ball right there? Now, that ball, and then there was another one on top of it on a strap that was like, these are straps on balls. It's like that. Now, that's all I can tell you. And I mean, I've looked at them. I know I have a zillion. I have so much stuff, it's embarrassing. Now, I'm going to show you what they look like. I mean, I'm going to show you hundreds of them. Just stay tuned. All right, you saw the anatomical look, all the little balls coming down. This is what it is right here. You see that? This is the kind of tendon. This is a tendon mat. There's other different areas how they invest, but this I'm going to show you. This is like the strap. You see? That strap comes over like this, and it goes through a Chinese finger trap, and then the ball is underneath. This one is ripped out. It's not supposed to be. That's a painful injury. Now, that's the ball on the other side of the Chinese finger trap, and that's what they are. And they're all over. Now, what this allows it to do is the strap can move back and forth as your muscles pull and your arms go, and your you know, all this stuff that you're doing is exactly what's going on here. Something is holding it, and it's pulling against it, and you're pulling back. There's a muscle in the middle. So there's always something. There's a strap, there's a tendon, there's a muscle, there's a bone, there's an anchor, and then there's something between it does this. And that's why whenever you see a tendon break, and if it breaks like in here, there'll be what they call a wrinkle zone. I'm going to show you some. This is fabulous stuff. And what it is because this is always under tension. This is an extremely strong fiber. So it doesn't do this. It doesn't do that much at all. It does this. And that's it. When it goes bang, you get a wrinkle zone at the end. In between where it snaps, you get a little, because it's always under, it's just always tension. And when it snaps, the wrinkle zone is here, and then the rest of it looks normal. You're going to see that, and you have seen that in a place that everybody knows. And everybody's going to freak out when they find out what it is. Now, this won't make much sense to you, but trust me, there is every part of you, like your fingers have these balls in them, your wrist, your arm, your face, your skin, your nose, everything has to be anchored. Because you move your skin, it's got to come back. So there's different balls, and there's different straps, there's different attachments, but they're all basically the same. There's an anchor attached to a strap, attached to something that pulls or moves. Okay, now this is the biggest tendon, which is the Achilles, and that is your big Achilles ball, and then the tendons run out like this, but they all have this specific look to them. And you're going to see a lot of this, and you're going to see it huge. Okay, so I explained to you, you have an anchor, which is the heel, you know, the heel bone, which is the Achilles heel, and then it comes up through the tendons up to the muscles. Now, these tendons, and don't forget, remember I told you about the abrupt transition and about the wrinkle zone? There it is right there. Now, let's take a look deeper, because you know, I'm going to just tell you where it is right now. Devil's Tower. You're going to see that exact same feature, and I'm going to show you what the fibers are at Devil's Tower right now. All right, this is what we're just looking at, these tendon fibrils. You see them? They turn into hex fibers all the way up until they're little tiny ones, but they're basically the same structure. And that is exactly what you see here. You see that? You see up the top? That's the abrupt transition up there. These guys are climbing up those tendon fibers. We are talking about creatures that the average human mind is having. I know they're having a difficult time accepting it. And the brightest minds are having the most difficulty. I'm sorry. You're going to have to, turn the brightness down a little bit. What I'm showing, there is no doubt, 100% certainty. I mean, I've had the DNA test done. My stuff is 100% certain. Hold on. Okay, this goes back about 5 years ago, and this is after years of being denied by Yale and Harvard and everybody to even examine them. And they're undeniable to look at. There's no anatomist on the face of the planet could say that's not a lung. That's a depression of the heart in the back of a left lung. There's no question whatsoever. That's the pleura of the lung. And, of course, it's DNA certified. So I got frustrated. I had it done 5 years ago. They still won't look at it. I had 3 different things tested, and 2 of them were giant humans. And so it is absolutely no question whatsoever. They did negative controls. They tested it. The guy said, the lab director, I had a discussion with him. He said it was dense for ancient DNA. It's because I took it right out of the arteries. I didn't swab anything. It's Homo sapien, mitochondrial B loop, or B gene, and a D loop region. So, I didn't want to have to pay to do this. I did it because I want to prove it. And they still won't look at it. They still refuse to even look at it. Very distressing what our university system is. And I think it's a fiduciary failure. I think it certainly could be looked at as a legal issue. I wouldn't want to be paying them for information related to this kind of stuff and find out that they didn't pay attention to what they should have. I've shown it a billion times. This is a thumb from my smaller giant, DNA certified. It's been CAT scanned, DNA certified. Anatomist looked at it. That's where the tendons lock in on this one. I'm sorry. This is what we have, and I have tons of them. I have them coming out of my ears. DNA certified. Time for reality, my friends. Okay, my friends, I'm going to just buzz through these. You see all these stone balls? They're everywhere around the world. Now, see, they're in layers. They come. Some of them are like that. Some of them come like a honeycomb. All right, they're just everywhere. And I get pictures from them. And I don't know. A lot of these are from people that, these are the ones that are stuck in. That's probably interstitial, skin. And some crack up like this, and you can see flesh sometimes. You can see. The kaolin clay sometimes. Sometimes they're just stuck up on top of the earth. They're everywhere. Now, these are probably from skin interstitial, when there's a zillion of them like that all over. And where do you see some of them? That's just the same shot again. What do we got here? So if the chemistry's different, it'll take on colors. Like that's probably copper area in that area. Sometimes they don't have like just regular onion looking. They have different structural things inside of them. It depends on where they are in your body. Now these are sometimes they're up on stalks like that, and they seem to be layered and they break in half quite frequently. There's one with 2 stalks going up into it, and that happens too. Some of them have just a single, some of them have 2. Here's they call this, I believe, chert. But you see these little squares inside of them? And even the Chinese, I think, or Japanese, they made plates out of these. You'll see some later. But you see them, they're all over the beach. What do we got here? Chaco Canyon might have been made out of some of those. Stone ball cluster, what do we got here? All right, so that's a house. And they just anchored whatever was there, and there was giant people. They were just giant people. That one there, that one could be an eye. It's called the eye of the dragon. And see the way it comes down, and it actually comes up like an eye. Originally, I thought that was just a round ball, and these were, but this could be the lens of the eye. And then when I looked at it close, it doesn't look like an eye. I mean, it does look like an eye more than it does look like a stone ball. What do we got here? Look at the size of that baby. Now, in the center of them, they have sand. It's a pure silicates. I've seen some of them all emptied out like that before. I think you did too. Now, there's the type that have a fabric. Now, the ones that have a fabric, I think they're able to do this sort of thing. And the other ones are just solid. They can't do anything. Now, this is from my buddy Lee Simpson. Now, these are, I think, in other words, they didn't carve those specifically, or maybe they just cleaned them up or something. But you saw all that honeycomb look on the other ones. Oh, here you go. There's Lee Simpson again. No, this one here is just all honeycombed. What do we got here? That I don't know. But these are the ligament attachments. This is like a bone to bone, and like maybe these are, I don't know, tibia, fibia. I really don't know, to be honest with you. Lily Lavender sent me this one. Now that ball right there is virtually identical to Iapetus. That's the same thing, looking like Iapetus. Some of them have this look to them. This is kaolin clay, washes away easily, and these are the balls that had held it there. And I've got a ton of those, and Tyson does too. Tyson's got them all over the place. See, that's the kaolin clay all washed away, very easily eroded, but the balls stay. And the strap would have gone up in here. The straps deteriorate much easier than the balls. The balls just don't. Now there's a stone ball that turned into an opal. Now, the reason opals appear, I got a feeling it's got something to do with, well, I know it's got to do with the chemistry, and something that invades the chemistry, and I got a feeling it might, I don't know, I don't want to make any, I don't want to even say what I think. All right, you see the size of this? I think that's tendon ball. I think these are tendon balls out here. And that would have been a tendon ball strap going into there that eroded away. That's why they find all these big, gigantic tunnels. They're blood vessels, they're straps, there's the same thing again. All right, here's one. Somebody was telling me they had the exact same thing. It might have been Tyson. I mean, he's got everything. Tyson's got the whole 9 yards plus another 50 or 60. Now, there's that plate I was talking about. They slice them across, and I'm sure that's the center of a stone ball. Now, I additionally believe that this is what they call chert, flint, that type of thing, I believe comes from that. These are up in Canada. These I haven't figured out. They look like watermelons or something. Look at this top of that thing. Like a cantaloupe or something. I don't know. I have no clue. Now, these are cool. This is skin. That was skin, and this is the interstitium balls of the skin. And then you can go like this. You can move the skin, and it's supposed to go like that, and then it come back and do all that stuff. When you're young, it does it nicely. When you get older, it's a little wrinkly, but it still goes here and there. These are supposed to be just locked into that lower layer. Well, it is eroded, and if you could look down in here, if you could look closely, you'll see that this is the basement layer of skin underneath the interstitium layer, which is the fleshy, gooey layer that is your soft, movable layer. And this is when they collect them up. They call them hematite nodules or something. All right, there's another one. See? These things are big, man. What do we got here? I mean, I got so much of this stuff. Here's the stalk, you see? And you might find one here, one there, but sometimes you find them just zillions of them in the same spot. See, there's a little blood left over there. You know, there's a stalk edge. This is what we used to cut stone, but they had the same sort of equipment back then. They had the same equipment. You think I'm kidding? I am not kidding. Now Stonehenge, this guy built Stonehenge. They had giants doing this, and the stones in Stonehenge are they're all body parts of a giant, and that is a giant's foot, and they call it the heel stone. And if you can't tell that's a foot, I don't know what to say. And that's the blood right there. See the black? There's black blood. This all could be tested. You could drill into there, and I'm telling you what, if you drilled in there a distance, you would find literally wet blood. I'm almost certain. Now these are the same thing where they had like tubes going in. I mean, the whole entire. And there's nothing that wasn't made out of body parts. Now they're cutting down into here, but that was some form of a body part. This is in Japan. They did the same things there. They cut these wet and put them in place wet. They were from the flesh of whatever was around. Look at that thing. All right, these are those, you know, sweat glands and the hairs. They found the sweat glands and the hairs all over the place. All right, so I'm going into something else. Now let's see, because I have tendon balls and tendon abrupt transitions and tendon this and that. So here, let's go through them. What the hell? All right, I showed you this. That's the abrupt transition. All right, this is the abrupt transition up here. You see what the wrinkly stuff is up in here? And it's all dripping out of there. That's something that's from some body cavity. Not cavity necessarily, but well, you can see what's going on. You know, there's chemistry coming out of there that's different than the rest. So there's a blood vessel or a nerve or some bile duct or something there. This is the gluey stuff on top of the tendon fibers. It's just the way it is. You have the fibers, you have the gluey, then you have your muscles or you have your bone. And I got them coming out of my ears. You can see them everywhere. This is more, you know, usually when you see them broken off like that, there's an abrupt transition there. And they're abrupt. I mean, they're just as flat as a pancake. Pete sent me this. Let's see what we got here. Look at that. This is the attachment spot. It's almost like a fan. You see it? And then you got this running out to the longer. And that's the way they are, abrupt transition. I have them in my own stuff. I show it in the microscopes. I show the exact same things. Well, this just tells you how the abrupt transition work. This is just, look, 2 microns thick. It's just as flat as a pancake. And they come with all these little stripes like that. That's how we're built. And well, I had a piece here. Hold on. I don't know what I did with it, but it had to have. It's about this thick. It must have had 20,000 layers. I'm not kidding you. You have no idea how many layers are in your. And well, here, look at this. Look at that. How cool that is. Now that's an abrupt transition. You see that? That is a tendon strap coming up to the glue of the abrupt transition. That's how flat they are. And that's something. It's time to look at this stuff for the reality that it is. Now here's Scott Wiles out in Oregon. Scott and Tyson got together and did a lot of work. Tyson's now on his own up there. Scott, I think, is down in Florida or he's traveling. This is the gluey spot between a bone, right, and the right above would have been the muscle. Now this could be, you know, this is the gluey stuff. Remember I talked to you about this before? That can move and it can do all this stuff, but boy, I'll tell you, it glues tight on this stuff. When, you know, the muscles though can erode. This stuff doesn't erode. The tendons don't erode. They're different chemical compositions. And what do we got here? That's that Achilles tendon. And you could see, I think, you see right there? That's an abrupt transition. See the way it's bent? And there'll be one over here, and you can see where, I know them very well now. I've been doing this a long time. This is the Achilles. That's the abrupt transition for the heel. That just shows the Achilles from the side. This talks about the tendon anatomy. See, remember, here it is right here. This is like the stuff that Scott and Tyson were working on. And these are the tendons, but where they come out at the end, they come out as hex. All right, you see this? There's the, you can actually see the wrinkle zone up the top. Wherever you see these colors, that's just not accidental colors laying there. Those are actually bacteria. Those bacteria, I think, live on sulfur. But there's different bacteria will live in different spots on the tendon. Sometimes it's green. Moss and lichen love. You see moss? Look at the moss growing on there. That's a balancing rock. There's a little piece of tendon, or I mean ligament up through there. But you see how the moss loves to grow on blood. This is what they look like in living people. That's, where are we going here? That is a gigantic tendon. Well, not gigantic. It's just highly articulated tendon ball. I think that was sold for a lot of money. All right, somebody took a tendon ball. You see this? This is a tendon ball. And they carved it into a baby, like a womb. Isn't that cool? But, and they will form agate inside. Depends on how the conditions of internment were of the different body of the creature. That's why sometimes they rot away, sometimes they turn into all kinds of different materials. What do we got here? All right, somebody made a ball out of this bowl a bazillion years ago and probably made it for, I don't know what they did. But they did a lot of things a long time ago. So look at these. Boom, 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 boom. What the hell is that? But you can see, you see on the side, this is tendinous material. Somebody carved it or did something with it. I don't think that's a natural, but I'll tell you, some of the natural things I see. All right, that's that is some kind of a biological thing. Almost everything that you see, even this, you see these? That's biological. You see a person there? That's the inside of a tendon ball. I'm telling you, and I will show you, the ball goes like this, and they have all of these fibers inside. All right, there's another wall somewhere that's got all these tendon balls on there. That would have been fascia. All right, this is what they look like in microscope shots. You know, there's a, you see the abrupt transition, abrupt transition, abrupt transition, and there's going to be more of them out there. And that's what they do. And this is the weak spot. This is weak. This is tough. All right, there you go. I think I've shown that before. All right, there you go. Arches National Park. That is a tendon ball. There's another one there. There's one over here, one over here, one over here. That right there is where one was when the strap came out, probably to this one, broke off already. The meat would have been right here. And remember I showed you one that was pulled out of the thing? Identical. Identical. The straps are less strong. This one just happened to be in a position that everything is working for it. But that guy's going to have to be a little cautious. All right, look at that. Remember I told you inside of bones? All right. Inside of that, if you could see, you see all those little tiny holes? That's what this is. This would be right on top of there. And then there's another bone on the bottom down here. And everybody can do what they got to do. And that will never come out of there. Whatever happened here, somehow it broke off. But this is in between this and the other bone. There'd be a little bit of meat wrapped around it. Alright, remember I told you there was tendons and there was tire tracks in them and they were cut in slabs like we have machines. They did the same thing. This is, look over here, see that? That's like tank treads. You see this? It's like tank treads. And then those wheels sunk in because it was wet, and this was a tendon. And I will show you this in extreme detail. Hold on. You remember what the tendons look like. That's what they are. These are the slabs they cut out of them from that tractor cutter, and then they built these walls in the back. This wall, they cut the bumps, they cut the chunks, and some of them still had blood in them. See, that's like a bone, and there's a blood leaking out of it. Normally they didn't use those. This one here, look at that, that's just a pile of scraps. Now, normally they would cut those out. Now, on these, you're going to see bumps here and there. You see that? Remember the original mat I showed you with those straps that went around through the Chinese finger straps, and then there was a ball on the other end of the strap? These are the straps. Now this, I think, was a test wall to see what the best way to use these things were, because I don't see any other reason for that wall. And I can see it's all made in different ways. And you see those little straps there? Those little chunks? That's normal. That was actually the fabric that's on this, on the outside edge of the tunica, and there's some on here and so forth. All right, here's the exact same machine, identical, driving through a different area where you can see as it drove through. This is mineralization, and this is a tendon as well, only this is selenite. However, that is the stuff right there that would be in this. This is a tendon, exactly the same sort of stuff, only this was in an area where the chemistry washed out all of the organics, took all the organics out except these like little mineralized places. This is also an abrupt transition. This was sent to me by Becky Dorius. Thanks, Becky. It was fabulous of you, my friend. Now, here's another one. That's an absolute perfect example. That somebody made a machine to do this specifically to cut these things. Then they used those things, and it was obviously wet. It didn't sink in there for no reason at all. And these came out perfectly perfect. And these walls were, everybody, oh, how could they possibly do that? They did it because they were moist. And they did this everywhere around the world. Petra was carved out of wet flesh. If you go into the treasury and look, you can see actually where there's blood leaking out of the walls, that they had to drill holes in it to let the moisture out of the walls. Here you go right there. There's the tendons. This, as I told you, this kind of rusty looking stuff, that's actually bacteria, and it's living on, you know, the biology. Remember I told you about the abrupt transition and the wrinkle zone? Look at that. That is, these are, each one of them is tendon fibril, and they were under tension, and they cut at the top, and tick, and they brrr. That's what happened. You see that? That is literally some kind of flesh. You see it? There's a Jeep or something. I mean, look at this. We're talking about things that the average mind just, it's I understand what you're dealing with if you've never seen this before, but you have to come to the reality that these things that were written thousands and thousands of years ago were apparently written factually. Okay, there's your wrinkle zone. Devil's Tower. That's what it is, my friends. I am sorry, but that is exactly what it is, the foot of a giant. And usually there's only 1 foot above the ground. They say, well, why is that? Well, one of them normally is pushed deep into the ground trying to push the other one out. These died in a great flood. I'm sorry, that was what was written, and that's what happened. And they tried to push themselves out of the mud. One's deep and one's up at sort of surface level. That's what I have discovered. Now, you could see here, I don't know if you can see in your monitor, but there's going to be a spot right here with a little bit of blood leaking out. Now, it is what it is. These are the wrinkles that wrinkle right around the bone of the heel. And if you look at the rear of this thing, there's two big brown blood spots in the calcaneus. I don't know what else to say other than that's what it is. And then you run into things like this. These are tendinous straps that were left up on the top of some other part of the biology that eroded away. And they find in all these crazy things that nobody can account for. There's the cuts in the tendon. This is what I call tendon slurpee, small leucine-rich proteins. Different types of tendons, different types of fibers. These things here, you see these all over the earth too. Those are well, they're these, which I think they're, what do they call that? It's more or less fat, and the blood is there to slurp up the storage of fat. What else we got here? Oh, these were the kids having a good time sliding on tendons. You give a kid a tendon, you know they just have a blast. What else we got here? I don't know. I could just go on all day. I have so much of this stuff. Tendons in space. And guess what? They are. All right, there's your Achilles heel again. I've sit through so many autopsies and so forth. Look at that puppy. I don't know if I'd want to be walking around and look at that. Yikes. These things were so tall, it just defies the imagination. Now, when you look at the anatomy of a tendon sheath and so forth, and synovial cavity, and it's fun. The anatomy's fun here too. Now, here's a selenite. See, that's tendon. That's exactly what Becky sent me. Only she sent an abrupt transition, and you really can't see it well, I don't think. Maybe you can, maybe you can't. See it straight across there? Isn't that fabulous? That's selenite. What else we got here? There's a big piece of selenite, but that's nothing more than a big piece of tissue. This is what the tendon in a scanning microscope looks like. A lot of it is straight board-like, and that's what I show a lot of. And then you get into the gnarly stuff. You know what they make? That is your, what do you call it? The jade. This was a tendon that was sewed back together. All right, there's a tendon repair, and they don't repair easily. I mean, they don't repair themselves easily. You know, you need to have surgery on most of them. All right, this is where they were, and it was moist. They dug it out with little shovels and things. They didn't do the kind of work that, they went out with chisels all day long. No, absolutely not. All right, this is also a tendon. Isn't that something? Look at the complexity of the number of fibers. It's absolutely staggering. Look at the way you see this. That is a foot. I'm telling you, I don't care what you say. You see those blood vessels? I mean, waterfalls? That's what they are, is blood vessels. During the rainy season, the pressure comes up, and they bleed through the arteries. Those were arteries. This is actually the layers of tissue. This is the heelish looking thing, and they made all the pyramids out of things like this. They made them from the top down. They broke those down and made them down like this. And they said, what about the angles to the earth? Well, maybe they could make an angle here instead of that angle there. They do whatever they want. But they started from the top. They didn't build them from the bottom up. And I have seen the inside of the Great Pyramid. I haven't been there, but I've seen pictures and movies of what it looks like inside. There's no question it's the inside of a foot. What do we got here? Look at that thing. That's just awesome. Now, I'm not exactly sure what it is, but it's obviously a structural something. Hair, I don't know really, to be honest. All right, there you go. There's some more of the tendons, and there they used them to build the walls in the back. They were prolific builders. All right, that's just another picture. I think we've been all through this stuff, maybe. Look at that. Yeah, tell me what about that. Somebody account for that. Oh man, I'll tell you what a world. No. All right, these are all the micro shots of all the different types of tendons. Those are some micros. They really weave in, and these are tough fibers. These are not your little weak puppy stretch and crack and rip open fibers. Those puppies are strong. Look at that. I mean, they had look up Krishna's butterball. All right, there's what the ball pulled out on me. Now, over in India, I think it's in India, they have a one of those balls sticking way up in the air like this. So you got the flat spot, and then the ball sticks up like that on a stalk that you can't even see. It's so small, it looks like it's on a pin. So they decide it's dangerous. They got 12 elephants up, they can't push it over. But those tendons are so tough. And this is the tendon mat. That's what it looks like. And this is what feeds them. This is what gives them some nutrition. Now, when you have this, that means there's going to be transition metals, because all blood and nutrition is made out of it's moved by transition metals. And I'll show you. Whoops, we're back to here. Where do you see this? Hold on. All right, these are the kind of transition metal colors. I understand these. I understand where they are in the body. I understand why they're there. I understand the chemistry that they're doing when they are there. And bile and urine and all of the different things have different colors. And blood and I can tell where I am in the body by the colors. In a lot of cases, sometimes not, because there's different chemistry that changes that. But I understand this quite well, and these colors are very, very important to understand. All right, I'm going to leave it at this. You saw the tendon mat, the little where I said it invests with the blood. This is where it is right here. This is the tendon mats. This is in China. This is in a lot of places, and they are extremely vibrant colors because they are from the transition metals. And when you see opals and so forth, dense with transition metals, that's what the colors are. You saw, I showed you the transition metal elements that are the colors that are aqueous solution transition metals. And what they do, just so you fully understand what transition metals do, they have a blank little spot in them that wants to attach to something and carry it around. So the different colors have different other elements that they can attach to. A color means I'm a different species. I can attach to something that's got this much, the next one's this much, the next one's this much, the next one's this much, and it just keeps going like that. And this one has maybe two, this one has one over here and one over here, and it just depends on the elegance of the program to what the molecule will end up being. All right? Or you can have a bunch of different ones together, and they all grab onto a bunch of other different ones, and boop, at the end they have one elegant, beautiful molecule that's designed to do a specific job in a creature's body. And it'll make another one identical to it, because that is the nature of molecular assembly. All right? It's not understood right now. They think there's just gigantic globs of this and that. No, there's nothing more than tiny electrons. Everything there is made of electrons. There is nothing other than electrons. Protons do not exist. Neutrons do not exist. They are accumulations of electrons that become stable at a resonance frequency of a certain number, and that number is in each one of these. And in between each one of these numbers, there is thousands and thousands of these little particles, which gives it isotopes and all of the other capability to chemistry to do the elegant reductions and growing molecules and all of the different elegance that happens. And it is not accidental either. It is from God. I'll leave it on that. God programmed bacteria. Bacteria programs molecules to invade cells as a program, not as a living thing. And when the program attaches to the cell, it reads it and it says, "Oh, you're program 2057. Yeah, okay, come on in." It comes in and it says, "What do you want me to do?" It looks at the program. It says, "Make a ton of me. I am here to go out and kill COVID-19." That's all it does. It makes a ton of them. They go out. They're supposed to kill COVID-19. If we don't have a program built into us to say, "Hey, COVID-19, no problem. I can take care of that." Say COVID-19, never heard of it. So your body says, "What do you want me to do?" He said, "Well, go kill the COVID-19. He said, "I can't." He said, "Why can't you kill it?" I said, "I've never heard of it." He said, "Well, I thought you were an enzyme. You were supposed to come in and help me. You were supposed to program and kill. You're my immune system." He said, "I'm your immune system for a human being, not for a bat and a snake. You guys are doing crazy stuff. You're on your own." Okay, my friends, I haven't finished the website, but this is the giant hand from that giant fingertip that I just showed a second ago. We're into light, and we can accelerate light, and light is shown now as a particle. It accelerates, so there's a lot of changes there. We have all of the evidence to support everything. The muscle is what you see. This is the size of the things. And Tyson, wait till you see what he has. And now we're deep into the biology and health, and we're finding out that what we are looking at, and I'm going to show you right now, is also what causes this new COVID-19, is tendon ball problems.